Alright, so in this question we've got a ball rolling off the table with a speed of 3, so it's going to roll off and fall like this. So this is a type of projectile motion. Our table is 1.2 meters, and we want to know how far away from the edge of the table it's going to land on the floor. So to set up our table, let's fill in what we know here. So our acceleration rate, we are always ignoring air resistance in our problems, so our acceleration is going to be 0 meters per second squared, and our y is going to be due to gravity, is negative 9.8. Our distance in the x is what we're finding, and then in the y it's going to be a negative 1.2. And we are assigning it a negative because we are giving everything that goes down a negative. Okay, if you mess that up, if you leave off the negative, when you go to calculate time, you're going to end up trying to square root a negative number, and that's going to be a problem. So our time we don't know, and our VI we know in the horizontal is 3, and in the y is going to be 0, because initially it's doesn't have a speed going down because of gravity. It starts accelerating towards the ground. So that's what we know so far. So first step we need to do is to be finding our time, because we ultimately want our horizontal distance, but we don't know a lot of information in the horizontal right now, so we need another piece of information, and we can do that by figuring out the time. We know more in the vertical, so we're going to use vertical information in order to find the amount of time, because the same amount of time it takes this ball to go down is going to take it to go over. Alright? So we're going to use the vertical to find time, and the formula we're going to choose is going to be our distance formula that we use a lot. And we're using this one because it's got everything in it that we need, alright? And that we know. So I'm adding the y's in here, these subscript y's, to remind you that we're working in the vertical. We know our vertical distance is 1.2. We know our vertical initial velocity is 0. So this gets canceled out. So I'm not going to copy it down again because it's going to be 0. And then 1/2 times negative 9.8 times our time squared. So when you multiply 1/2 times negative 9.8, you're going to get negative 4.9. You're going to divide that by negative 1.12 by that negative 4.9. That's going to leave you with 0.24, and that's going to equal t squared, okay? And then you square root that, you get a time of 0.49 seconds, okay? So that's how much time it takes, and that goes in both of your columns, okay? Because the same amount of time it takes to go down takes it to go over. So now we know enough information in the horizontal in order to solve for our horizontal distance. So to do that, you are going to use the exact same formula, but this time we're going to be working in the horizontal. Alright, and I've added x's in here just to remind you that we are working in the x direction. Okay, so we're solving for our horizontal distance. We've got initial velocity of 3. Our time that we just found is 0.49. Oops, sorry. And then our acceleration horizontal is 0, so all that gets canceled out. So again, I'm not going to write that down. And so all you're doing is multiplying 3 times 0.49, and you are going to get an answer of 1.47 meters. So our horizontal distance and the answer to our question is 1.47 meters. All right. So I hope this video helped you out. If you still have questions, please let me know in class.